So we are now ready to do a complete example. Before I present to you the example problem, let's go over some principle in this particular slides. So when are contracts complete, especially when you specify a post condition on the obligation for the supplier? In the post condition, for each attributes in your class, you should really try to write some condition in the post states and relate to the pre states to constrain the supplier. Specify the relationship between the pre states value and its post state value. So I will support this using the O keyword, and we talked previously about how the O expression can trigger automatic caching of the pre-state values. Actually, see, this is really tricky, especially when your attribute type is actually composite, like a collection type array, hash table, linked list, tree, and etc. Okay, and then if your attribute value is simply primitive typed, like an integer or boolean, is much simpler, but you cannot rely on that. You have to know both cases. So what's the rule of the thumb? For an attribute whose structure is composite, like an array, we should specify that after the updates, two cases. Case of change, you want to make sure the intended change is present. For example, you want to change a position I to be some value v. So that will be, you want to make sure at position I, the value has been changed to v. And second, the rest of the structure is unchanged. So every index except for index I should remain unchanged. So now the second contract over here I highlighted is much harder to specify due to two dimensions you have to worry about. First dimension is about reference aliasing. You want to make sure, remember the previous example we did about the old imp versus imp. Depending on the kind of change you might make, either at the first level or maybe beyond the first level. In that case, doing a reference copy, shallow copy, or deep copy can make a difference. Of course, using the deep copy is always the safest bet. However, you want to make some educational judgment to use the cheapest possible. If you can simply use the shallow copy without using the deep copy, you should really opt for that. Okay, and also the iterable structure, you have to use a cross notation, or you have to specify some logical quantification in order to do it. Okay, we'll see example to illustrate this exactly. Okay, let's set up the context. We're going to talk about two classes, account and bank, and these two classes are very similar to when we talk about the caching in the previous example. We just expand that a little bit. Let me just go over the code with you. You can study that yourself. It's very straightforward. So we get a class called account, and then we define the is equal for equality, and then we have a constructor make, and then we got owner, we got balance, okay, string and integer, and then we can initialize the owner and balance, and the balance simply initialized to be 0. Okay, so we don't take any parameter over here. Okay, and then we got deposit. So rather than talking about withdrawal, we talk about deposit in this case. For the deposit, let's just assume the amount is simply non-negative. Let's assume. So we simply got balance incremented, and also for the post condition is also quite conceivable. Okay. And then we have is equal here. So what does it really mean for two account object to be equal? The owner should be the same and the balance should be equal. So now let's talk about the bank, which is more important, especially you have to worry about composite structured attributes. So we have over here, we have the bank, which has a constructor make, and then here we declare this particular attribute here, accounts of type array of account. Okay, we have seen this client-supplier relationship already in the previous part. And then we simply create an empty account to begin with. And then, so this is the most critical feature. Please make sure you understand what this feature does before you move on to the next part, because all the versions we're going to present relies on this particular feature. Account of is like a query. Given the owner name of some account, if they exist, we're going to return the corresponding account objects for that particular account. For example, if I give Steve over here as the name, I want to return Steve's account objects in the bank if Steve exists. So now what about the precondition? You want to make sure, for example, Steve should really exist. Pause the video and think about how you can specify this precondition using quantification, either they exist or for all. Okay, assuming that you have thought about it, let's see what the solution might be. You can use to say across the accounts, the array, we want to make sure at least. So that's why we use the sum. There exists an account object whose owner is equal to n, which is the parameter. Okay. However, can you actually use, so here we are using existential quantification to actually write it. Can you use for all to write it? The answer is you can, but let me give you a little bit hints and you can try it. Remember in 1090, you learned about a very useful theorem to convert between universal and existential quantification. So let me just write it down, and then you will be able to convert, adapt into Eiffel syntax. So let's say if we have for all over here, let's say for every x, some dummy variable, such that, okay, so let me write it properly. So now let's say such that x satisfies some range constraint. So this is the range constraint. It is the case that some predicate p is satisfied. Okay, of course we can simplify this by convert this into implies. We can do that as well, but let's not worry about it. Okay, so that's the general form for all. Okay, so now what would be the corresponding exist? So that would be double negation. It will be not the case that there exists x such that if we satisfy the range, it is the case that not px. Okay, and vice versa. You can actually do this double negation conversion. So I'm not gonna go into the intuition behind these two predicates. If you really got trouble, please speak to me. Otherwise, I'm gonna assume you're okay from the previous logic course. Okay, assuming that you understand how it works. So now if we go back here, so now you will be able to convert that into the from exist to for all by applying negation and also negation, double negation. Okay, and then so for the account of the implementation should be quite easy. You simply go over the array and then check the owner for every member in the array, the account. If the owner is equal to n, then you return that particular account object by assigning result to it. Okay, so I'm gonna omit that implementation. So now again, please make sure you understand exactly what the account of is supposed to work before you go on. Okay, I also made the source code available to you. You can find the links in the slides. Also take a look at the source code and play with it. Okay, so now we also got a command over here to add a new accounts by the owner, right? And of course, the precondition should be the owner has not existed in the bank. Pause the video and think about how you can do it. Okay, assuming that you have thought about it, let's now see non-existing should be go across the accounts. In this case that all the owner is not equal to n, which means the owner we want to add into the bank does not exist. You can also convert this using existential quantification, using the conversion theorem I just mentioned to you. Okay, that's something for you to check. Okay, and then how do we add? You simply just try to create a new account object over here using the owner name, and then you'll simply use a force feature over here, right? Just force the new accounts into the position over here. So we talked about how you can use the force feature, the force command for array in the introductory tutorial videos. I assume you're okay with that. Okay, so let me talk about the roadmap of all the versions that we're going to illustrate before we move on to the next part, just for you to get some mental readiness for what we're going to illustrate. So we will examine in total 5 versions of a command. Okay, we're going to talk about deposit on. Okay, so that's a deposit feature command that we talk about. So we want to deposit into owner with this amount of money into their account. Okay, assuming that the amount is simply positive, we can make that assumption. So now we're going to see 5 versions. In version number 1, we are lucky. The implementation supplied by the supplier is actually correct. However, even though the contract is actually incomplete, I will explain when we get there what I really mean by incomplete. Incomplete simply means you only worry about what has been changed, but in the post condition it did not specify what about the rest of the structure. They should be unchanged. Okay, but now we are lucky the implementation is simply correct, but with the incomplete implementation there wouldn't be any contract violation, but that's more or less okay, but it's not really satisfactory. Okay, that's version number 1. Version number 2, in this case the implementation is actually wrong. Okay, when the implementation is wrong, we expect the post condition to occur. However, because the incomplete contracts or the incomplete post condition will not catch that. So having something that's wrong but without any contract violation due to your post condition being incomplete, that should be unsatisfactory. Okay, that's version number 2. version number 3, we keep the wrong implementation. We want to eventually have a post condition that's actually both complete and satisfactory. Okay, so now the first version we use is by specifying also about the rest of the structure to make sure not only that slot number I is actually going to change, but also the rest of the array is going to be unchanged. However, in the first version, we only try to use a reference copy to copy the pre-states. However, it turns out if we only try to make a reference copy of the pre-states, we will not be able to catch the error. Okay, so now it's still not satisfactory. Similarly, if we try to use a shallow copy of the pre-states, we still are not going to get a satisfactory result. And finally, if we try to make the pre-state using the deep copy, trying to copy the pre-state using deep twin, in that case, we will be able to signal a post-condition violation, which is expected. So now it will be satisfactory. Okay, that's kind of the roadmap for this illustration. Okay, so let me just talk about something very quickly, just about how each 5 version is going to work. So each of the 5 versions is going to have this particular object structure to start with. Let me show you how we can end up being here. And also we're going to use test cases, similar test cases to test each version. Okay, so this is going to be the skeleton. Each test case will be more or less the same structure. Let me just talk about very quickly. So for each test case, we're just going to it's going to be a Boolean test case, which means we're testing the return value of object states. We're not testing for contract violation in this case. So for each test case, we have a local variable b of type bank. Initially, we simply create an empty bank. Okay, let me just visualize for you. So that means b is pointing to a bank objects. If you refer to your source code, bank is going to initialize the accounts to be an empty array. So that's an empty array. And then we're going to add 2 account objects, right? So now for the first one, over here, we're going to add Bill as the owner. So now the first slot is going to point to a new account object over here, an owner and balance, right? The owner should be Bill. Okay, I'll just say B here for short. And then the balance initially should be 0. Okay, and then the second one, we're going to add another account called Steve. So now here we're going to just force another member into the array, and now this will just be another account for the bank. So now also account objects. Also we got owner, we got balance. The owner should not be Steve. Okay, I'll just say S just for short. And also we got initial balance to be 0. Okay, that's kind of the setup we want to start with. And then we simply want to deposit some money into the accounts, and then afterwards, for example, we want to deposit, let's say, $100 into Steve's account. So conceptually, what we really want to achieve is like this. We want to deposit into Steve's account. Of course, we have to search through the array to see which owner actually is Steve. Once we found this particular account over here, we're going to deposit $100 into it. So afterwards, we would expect to see. So now you can see this shows the use of account of. Right? You can see over here. Let's see this. Let me be very precise. B, the bank, the account of Bill. Bill exists over here. So that means this particular blue expression over here is going to return this account objects over here. And then we want to say its balance is actually 0. Okay? Similarly, so now let's try the next one. So if I say B the account of Steve, Steve also exists over here. So B the account of Steve is going to return this particular green account over here. And then when we try to say this particular account, the balance is going to be the one that we have deposited. So that's 100. Okay. So the same test case is going to be in place for every version, more or less. But once you see the source code, you will see the exact difference. So now, starting from the next video, we actually talk about each version.